Hi family, welcome to my channel. In this tutorial, I'm going to explain the Millis function and demonstrate how to use them in your amazing projects. One advantage of using the Millis function is it enables you to set a delay for an action or task without pausing the program. Hence, there's no traffic in the program, which makes the Millis function an ideal option for multitasking. These are the components needed to build the circuit. Starting off, let's insert the Arduino Nano. Now the LED. We connect the resistor to the anode of the LED. The other terminal to any digital pin. I choose D5. Now let's connect the cathode to the ground pin. There we go, the circuit is complete. Connect the USB cable to the Arduino Nano and the PC. The Millis function returned the amount of milliseconds since the Arduino board started executing the active program. In about 50 days, this number overflows and returns to 0. I'm going to print the Millis function on the serial monitor now. This line initializes serial communication at a baud rate of 9600, and it enables us to print data to the serial monitor. The faint sentence after the 2 slashes is a single line comment. It is used to describe how a program or command works. It is ignored by the compiler. To use this in your code, simply type 2 forward slashes, and anything that appears after the slashes on the same line will be treated as a comment. This line then prints the milliseconds since the board was powered up. Let's verify our code. Great, we have no errors. Before we upload, we have to set board and port. Go to Tools, Boards, Arduino VR boards, then you select the board you are using, in my case Arduino Nano. Unplug the USB cable from PC, back to Tools, Ports, take note of the available ports, insert the USB cable again, Tools, Port. The newly added COM is the port of your board. Now let's upload. Done uploading. Click on Serial Monitor. The baud rate should match the one in the code. This is the milliseconds passed since the Arduino board started operating. Let's continue with the code. Generally, the if condition is used when applying the Millis function as a delay. It demands for 3 variables to store different time sections. These variables are current Millis, previous Millis, and interval. I will explain each line of code for better understanding so you can apply them in your amazing projects. Without much ado, let's get started. The hash define is another way to declare a constant. It defines pin 5 as lead pin. This variable stores the previous Millis. Unsigned long is a data type that can store numbers ranging from 0 to 4294 million. This stores the delay or interval. Const long is the data type. This holds values to change the lead state. This line sets the lead pin as output. The Millis function we previously observed on the serial monitor will be contained in this variable. This is the condition, and it says that whenever the difference between the current Millis and previous Millis is greater or equal to the interval, the statements in between the parentheses should be executed. This is a very important statement. It guarantees the above condition is always true by updating the previous Millis with the current Millis. This statement alternates the lead state value between 1 and 0 whenever it is executed. Just as in digital electronics, 1 means high and 0 is low. This sets the lead pin to high or low based on the lead state value. Our code is complete. Let's upload it to the board. When the upload is done, the LED will alternate between on and off state at an interval of 500 milliseconds continuously. This is because codes written in the loop function runs repeatedly. There we go. If you made it to this point of the video, God bless you.